Okay, today we're going to be doing question 238, product of an array except self. I did this question before, but the way I did it was a little bit more complex. This is another technique and another way of doing this question, and we're basically just doing a lot of review, so we're going to make this video again, right? So the question says, given an integer array called nums, we want to return an array called answer, such that answer index I is equal to the product of all the elements of nums except nums I. So the product of a product of any prefix or suffix of nums is guaranteed to fit 32-bit integer. And we have to write this algorithm O of n. What does O of n mean? That means that it has to loop at least like through the entire array once, right? If we make a nested loop, that's O of n squared, which we cannot do, right? We're not trying to hard code it. We're trying to stick with this notation. So in simple terms, what that means is for nums, you see 1, 2, 3, 4, and your output's 24, 12, 8, 6. So how that works is we need if we start at 1, then we need to multiply 2, 3, and 4, which is 24, and you save it here. If it's 2, then 1 times 3 times 4 is 12. If it's 3, 1 times 2 times 4 is 8. And if it's 4, then 3 times 2 times 1 is 6. So you see whatever index we're on, we need to multiply the numbers that aren't that index and then put it at that specific spot, right? Cool. Now we have an idea of how to do that. How are we going to go do that? Well, we obviously have to do a for n, so we're going to do for loop, no nested, and we're going to do that twice. But before we do that, just like in the other video, I'm going to show you an example. So we are going to, let's say we have 1, 2, 3, 4. So 1, 2, 3, 4. This is a technique where if you have left and right, and you basically multiply the left, keep track of that and the right numbers, and keep track of that and add them or multiply them, they will actually be your answer. So for instance, let's say if we start here, right, all the values to the right are 2, 3, 4. So 2 times 3 is 6. 6 times 4 is 24, right? And everything to the left is just 1, right? And you put commas here, right? And you move the x or the pointer or whatever. And then everything to the right of 2 is 3 times 4, 4, 8, 12, right? And then everything to the left is 1. And you do it again, right? Right? Everything to the right of x is 4 times 1 is 4, right? And everything to the left of x is 2 times 1, which is 2, right? And then lastly, move the x one more time. Everything to the left is 3 times 2 is 6. 6 times 1 is 6 still. And everything here is 1. So 6 times 1 is 6. 4 times 2 is 8. 12 times 1 is 12. And 24 times 1 is 24. 24, 12, 8, 6. Make an array. And 24, 12, 8, 6. So you see how this is the technique that we basically need to follow to get the answer, right? So now we know mathematically how we're going to get this, right? We basically need to keep track of left and right and multiply them together. Beautiful. Now, how we do that in code? Well, it's actually not that complicated, and I'm going to show you. So obviously, the first thing we need to do is if we're iterating, right, and we're going to be looping twice, we need to keep track of the length. So in order to keep track of length, we're literally just going to call this n, and it's going to equal the length of nums, right? And then now as we have the length of nums, we need to keep track, or not keep track, we actually need to make an array. And we're going to make this array 1 times n. And then what this is going to do is actually create a placeholder where it's literally just a ton of ones, right? Why is this? Well, because now we have the length and we have our placeholder, we're going to be updating these values or this res consistently, right? Actually, it says we want to return the right answer. So we're going to follow and make it name answer. Okay. So answer basically just equals 1, 1, 1, 1 for this example. If it was any other, then it would just increase. But we're going to look at 1, 2, 3, 4. So beautiful. Now we have a placeholder called answer, and we have the length of nums, and it's set equal to n. How are we going to keep track of the left values and the right values? Well, first, we're going to keep track of left. So the first thing we're going to do is make a variable called left, and we're going to set that equal to 1, right? And we're going to create a for loop for I in range of n, right? Beautiful. So for I in range of n, what we're going to do is we're going to set, oh my god, I think it's left. No, result, or not result, answer at index I equals left, and then left times equals numbers at index I. Sorry, we had a brain fart here. Okay, beautiful. So we're looping through the range of n. I is the index. Answer at index I is going to equal left, and left is going to equal nums at index I. So this is a lot, and what we're going to do is actually visually show you how this is going to look, right? So answer as the moment equals these blanks, and left equals 1. So answer at index I here equals left. So this is going to be 1. And left times equals numbers at index I. Well, this is nums. So nums at index I is 1. Left, 1 times 1 is still 1. Answer at index I, now we're here. This equals left, this equals 1. And left is going to change to times equal numbers at index I, which is 2. So left is now 2. Now we're here. Answer at index I equals left is 2. This turns into 2. And left at index left times equals numbers at index I, which is 3. Left becomes 2 times 3, which is 6. Answer at index I equals left. This is 6. And we end the loop for the range. So now we answer equals 1, 1, 2, 6. Notice how this is 1, 1, 2, 6. Now we have left up in here. Beautiful, right? Now, as left is done, we have to do right. So right is going to equal 1. And same thing for I in range. But this time, instead of starting at the beginning, we're going to start at the end, right? It's going to be n minus 1 minus 1 minus 1. The reason why I do this is this allows us to start at the end, right? And we're basically going to do answer at index I times equals right, and then right is going to equal or multiply equal nums at index I, right? Beautiful. So same thing here. We're going to create a demonstration to show you what it's going to look like. And right is going to start at 1. There we go. Okay. So answer at index I, right, times equals right. Right is 1, so this stays 6. Right is going to equal nums at index I. So right is 1 right now. 1 times 4. This becomes 4. Beautiful. So now the next one, answer at index I, 2 times equals right. Right is 4. This becomes 8. And right, which is 4, is times equals nums at index I, which is 3. 4 times 3 is 12. Now nums at index I is 1. 1 times right, which is 12, is 12. And right times equals the number at index I, which is 2. 12 becomes 24. Answer at index I times right, 24. And we end the loop here, right? Now, as you see, we have 24, 12, 8, and 6. If we take a look, 24, 12, 8, and 6. Answer, our array, has started from here. We multiply the values back, right? Allowing us to actually get the answer. So if that's already done, then all we need to do is return the answer, submit it, and this should be correct. Should be. Oh, I lied to you. Endnet block at lines n equals the length of nums. Oh. Okay. Indentation error. Let's see if this works. There you go. Submit it for test cases. And done. Okay, cool. So the last time I did it, it was a lot longer and a lot more complex and somewhat of a 2-pointer question. But really, all you need to do is just have 2 for loops and I guess have 2 pointers for left and right. As you can see, we stick with the O and a notation because we are just have single for loops here. A single for loop is just O of n because you're iterating through the entirety of the list at least once. So that tracks off this. we made sure to call this answer, which is why it wants us to return the answer array. This is an array because it's just starting at -1 times n and isn't like the nums, which creates this little table of basically your mapping out of the answers. The answers starting here at this little section basically turns it all to all the left numbers. And then here we basically get those left numbers and multiply it with these, which is the right, allowing us to instantaneously update it consistently and being able just to return it.